In September 2022, Unity released a long-awaited multiplayer framework called Netcode for GameObjects. It put an end to the long period when Unity hardly had anything to propose in the theme of multiplayer games. The native solution was outdated, deprecated, and simply terrible. But Netcode is a game changer. This tutorial will help you start with your own project. You can visit this page for more information. The link unity.com/product/netcode is provided below this video, alongside with the links to all downloadable that you might use in this tutorial. Let's start by creating a fresh Unity project. You can use URP, but I will rather try the 3D as a bit faster option, and I will call the project Hello World after Unity own example. Creating this project will take a few minutes, but fortunately we can use the magic of video editing to warp the time. Once the project is ready, we will install Netcode for GameObjects using Package Manager. It is important to switch the packages to Unity registry. Netcode is somewhere here. Yeah, it's in version 1.0.2, and let's now click install to install the package. It takes a couple of minutes, so I will use time warping once again to speed things up. Okay, let's close the package manager. We will not start this project from scratch. Instead, let's download and use the Netcode Starter Unity package, which I have already downloaded and stored on the desktop. So let's install it now and import all the assets. You will find the link to this package below the video. Reload the scene. And here it is, a rather simple scenery. At this stage you can try the project. Okay. Various elements of the user interface are not yet connected and won't work, but you will find them useful at a later stage. You should be able to control a simple player character with WASD keys or the mouse. When you press the play button again, you will notice that Unity Editor takes some time to start your game. To speed the process up, go to Edit, Project Settings, here, and it's opened on the second screen, sorry. It's here. Choose the editor, here, and then scroll all the way down to find a checkbox named Enter Play Mode Settings. Check this checkbox and ensure that the two other checkboxes below remain switched off. Done! The game will now start much faster. Setting up the objects. First, create an empty object and name it Network Manager. Press Add Component and choose Netcode Network Manager. This will add necessary networking management services. Look through the options and properties in the inspector. We also have several messages here. Access additional tools for multiplayer development by installing the multiplayer tools package. You can do it later, so now we will just dismiss this message. The other message here is more important though. It says no transport selected, a transport is required for Netcode to work. Which one do you want? So we can select transport with this button, either Unity Transport or UNet Transport. The Unity Transport is our choice. This other one is generally deprecated and only kept for backward compatibility. Now locate the player object in the project hierarchy. It's this guy. Notice the player controller script properties here, and click the Add Component button again, this time Netcode Network Object. This will enable the player character to be spawned and controlled across the network connection. The next task is to make the player object a prefab. In order to do it, create a new folder and name it prefabs. Now move the player character to this folder and eventually remove the player from the scene. It should only exist in the project as a prefab, and it will be automatically used to instantiate your players' avatars. Now select the network manager in the project hierarchy and locate the player prefab in the inspector. You need to drag your newly created player prefab and drop it here. If you can't see the prefab, remember it's in the prefabs folder here, but I can still see it in my assets, so just drag and drop. Just below you should see a list called Network Prefabs. Click the plus sign and then drag and drop your prefab again, so it also appears as a member of that list. You are nearly ready for the first multiplayer test. You can enter the play mode. A warning should appear. It says that the current scene was not found in the scenes in build and so on. Would you like to add it now? Press yes. It is now important to ensure that your scene appears in the build settings, the scenes in build list, and it is indeed here, so we can go ahead. Whilst playing, you should be able to access buttons in the project manager's inspector: Start Host, Start Server and Start Client. Notice, these aren't the buttons you are looking for.
These aren't the droids we're looking for.
The UI buttons are not yet connected and don't work. The buttons you are looking for are here in the inspector, and if they aren't, ensure that you have selected the network manager in the hierarchy. You may need to click a bizarrely named object Don't Destroy on load. The network manager is its child object. Let's try and start host. You can see that an avatar representing the player has been spawned on the map. It is quite characteristic for the host play mode. There are 3 different game modes in Netcode. The server manages the entire network gameplay across the network, but not on the local computer, therefore it will not spawn an avatar. The client mode allows for the gameplay on the local computer, but requires a server to be active somewhere in the network. It will spawn an avatar. Finally, the host mode is a combination of a server and a client both running on the same machine. In that way, it is kind of self-sufficient and additionally allows for the gameplay across the network. As you can see, the host mode is practically fully functional. The server mode is also fully functional, but it doesn't allow for the local gameplay, so there is no visible avatar. The client mode doesn't display the avatar for a different reason. We have no means at the moment to run a server. So, prepare now for the multiplayer experience. Multiplayer games are normally tested by running one instance in the editor and another instance, or several instances, from the build. Firstly, go to the build settings. Your scene should be registered in the in-build list, so go and press the Player Settings button. You can put some sensible information as the company name and product name, and then locate the Resolution and Presentation section, which can be collapsed like this, and in it change the mode from full screen to windowed and the screen size to 1280 by 720. You don't want to run your networked instance in a full screen mode. Then go back to build settings and press build and run. The system will ask you for a build folder. I will call my just B, like this. Select folder. Save the scene if the system asks for this. And this starts quite a long process of building the application, which fortunately we can time warp. Yes, that's great. We have a build up and running, but oh, the user interface buttons are still not connected, not working, so there is nothing we can do with this build right now. What we have to do is to add at least the simple user interface. In order to do that, first of all, locate the canvas in the hierarchy, make it visible on the screen, unroll it, and find 4 buttons: the host, the play, the server, and the shutdown buttons. Next, we will create a UI script for the network manager. So, switch to the main assets folder and create a new C# script, naming it, for example, Hello World Manager. Before starting Visual Studio, you may want to navigate to the Edit menu, Preferences, and External Tools. Ensure that the external script editor is set to Microsoft Visual Studio 2022 or your other favorite Visual Studio version. You don't want to see Open by File extension here. Now, double-click the script to start Visual Studio. Here is the code of the script. We will add a new function, Start Host. It will handle the Play as Host button clicks. It will use the Network Manager class name. Note that Unity has automatically added Netcode to the list of dependencies. Now, the singleton is a special object within this class. The point is that there should be exactly one instance of the Network Manager class in the system at any time, and the singleton pattern does exactly this. For that singleton Network Manager, we will simply call a function called startHost, which will do the job. And that's the complete handler for the startHost or playHost button handler. Now, select the startHost function, copy it and paste it 3 times. Once for each remaining button. We need to change the identifier from startHost to startClient, both in the heading and in the internal call. Repeat this for create server and shutdown, and it's done. Save the file and go back to Unity. In Unity, we have one important task to complete now. We have to connect our newly created script with the buttons of the user interface. In order to do this, locate, for example, the host button within the canvas in the project hierarchy, and check the inspector, scroll it down a bit to find the section called onClick. Now we have to connect our network manager with the onClick event of this button. In order to do it, we will drag the network manager and drop it here. Now select the right function from this list. And we have a small problem here.
Say again, please?
Houston, we have a problem.
Fortunately, it is not a very serious problem. I just forgot to add our Hello World Manager script to the Network Manager object. I will do it now. Just drag it and drop it here. And now repeat the operation. Select the Play Host button, go to Inspector, find onClick, select a function, from Hello World Manager click Start Host. Done! Now repeat the same procedure for the Play as Client button and Start Client function, the Server button and Start Server function, and the Leave button and the Shutdown function. We can now try the new user interface, hit the Play button and press Play as Host. And it's working. I have fully functional avatar here. I also have these W letters here in the text box, but I don't care, it can be fixed later. Stop the game now. I will also rearrange the scene a bit so that I can see the map rather than canvas. And now go to File, Build and Run to prepare for the multiplayer gameplay test. Yes, save the scene and warp the time-space to speed up the build. Okay, great. We have a build. The point of this little exercise is to have two instances of our multiplayer game. So one instance is here. I will move this window a little bit sideways. And the other instance that we can use for test playing is in the editor. Let's rearrange this window so that we can see both games at the same time. Let's start the game in the editor, and now I have two working instances. Let's say I will play as a host here, and you can see that I have a host. I can walk around, okay, but now I can go to the editor and play as a client. And in this case, I have, for the first time, I have connection between the two applications. Two things to notice. First of all, any kind of movement is quite strange because, as you can see, I can move in any of these two instances. I can move two avatars at the same time. So it should be limited. I should only move the avatar that I own, not the other one. So in a few minutes I will demonstrate how to fix this problem. The other quite obvious problem is that no avatar movement is transferred across the network. A few other things to notice. I started here as a client. I can leave at any moment, and my avatar has disappeared from the other game. I could restart as a client and it's back. But if I leave the game which I started as a host, because the host is also the server, when I leave from the host, it's the game over for both players. Another thing to notice, if I just play as a client, nothing happens. I can have two clients, nothing happens. But if I start, let's say here as a server, nothing happens because the server does not support local gameplay. But if I have a running server here, I can use the other game as a client. Okay, so still no transmission of the movement of the avatar, and of course I only have a single avatar because I have a single client. The other game is the server, but it should work as well. You can try a configuration in which you may run several instances of the build game and find out that you need just a single server, and this single server can collaborate with several different clients. So let's move on now to player movement. The first problem we will address is transmitting the player movement across the network. And it is quite easy to accomplish. We have to edit the player prefab, which is either here or here in the prefabs folder. Double click it, it's here. Now go to the inspector, scroll down, click add component, netcode, and this time we will take network transform, a special class designated to transfer the transforms, so position and rotation and the scale of an object across the network. It's now added, it's here. First thing is syncing. We can synchronize position, which we want to do, rotation, and scale. Scale will not change across our multiplayer instances, so we can uncheck this. And our avatar only rotates around the y-axis, so we can also uncheck x and z. This is for the optimization of the traffic of data across the network. Finish edit mode, go to file, build and run, and let's have a test on 2 instances of the game.
Time warp.
Okay, test time. I will rearrange the main window again, and this like this. Play as a host here. I have an avatar, and play as a client here. Go back to host, and yes, I now have the movement of my player transmitted across the network to here. But the problem is that I'm still controlling the other avatar, so I'm controlling 2 avatars at the same time. So switching off this, and back to the drawing board. We need to edit the main script controlling the player behavior. So let's go back to the assets, and that's this file. The first thing to do is to change the base class from mono behavior to network behavior. You may also need to add using Unity netcode, or just use the functionality built in Visual Studio to get it done automatically. Now, the new base class gives access to many useful functions and variables such as isOwner, which allows for testing the ownership of the object. It can be used to distinguish between the avatar owned by the local user and other avatars belonging to other remote users. And this is exactly what you need to do in the update function. Character navigation should only be available if the current process owns the avatar. This should do the trick. You can also optionally add a new function called onNetworkSpawn. This function is automatically called by the network when spawning a new avatar in the game. You can use this function, for example, to set up a random positioning for a new avatar, but it is also important to guard this instruction, this positioning, with the isOwner test, so that you only set up the random position for your own avatar and not other players' avatars. We are now ready to save the file, exit Visual Studio, go back to Unity and initiate, build and run. Okay, so the next testing session I will use the build instance as a host and rearrange the main window, start it and use it as a client. Back to the host application. Can I control my avatar? Yes, I can. The avatar movement is transferred across the network, and more importantly, I only control my own avatar, not the other one. How about the client application? Can I control this? And a bit surprisingly, the answer is no, I can't. I cannot do anything from the client application. How come that is possible? Netcode uses something that is called server authoritative model. This means that the server is the only authority capable to transfer movement across the network to the clients and not the other way around. This is exactly what we have just seen. In this model, clients simply have no right to move their avatars across the network, and they have to request the server to do so. You could say it's quite stupid, but this logic protects your game against hacking, lagging, and also allows for precise synchronization, for example in physics simulations. Fortunately, there are at least 3 different ways to resolve this difficult situation. The first one is using the client authoritative network transform. This is basically about replacing the netcode default model with one which is unrestricted and allows clients to transfer movements across the network. This method is easy, but attention, it is not recommended by Unity. Still, this is exactly what I am going to do in a minute. The other 2 methods have many important benefits, but they are also a bit more complicated, so they will be discussed in the second part of this tutorial and not here. Back to Unity, and let's edit the player prefab. In its inspector we can find the source of all our misfortunes. This is the network transform component. This component defines netcode behavior model as the authoritative server, and this component has to be replaced. But the solution is right here. It is called Better Network Transform. This is a script you can download using the link provided below this video, and the script which I have already downloaded and stored on my desktop. Drag it and drop into Unity. Once it is done, double-click to edit the file in Visual Studio. As you can see, this is a very minimalistic class. What's noteworthy is the base class, none the other but network transform. And we have just one overridden function here, which is onIsServerAuthoritative. And this function returns false. I think this doesn't require a comment. This inherited class just changes the behavior from server to client authoritative. Back to Unity. I will once again edit the player prefab to locate the source of our mishaps, the network transform server authoritative component, which will be now removed and replaced by the one from the assets folder, the better network transform, which I will just drag and drop here. It is now visible in the inspector. It looks pretty much the same as the previous one, but it's better because it's client authoritative. Now I will switch off the scaling and rotation around X and Z, exit the edit mode for the prefab, and I am ready for the final build, run and test. Okay, and we have the final test. As previously, I will run this application as the host, moving it slightly to the right, rearranging the windows, and here I will have my client. So, first thing, can I still move the host around, the server around? Yes, I can. Can I do the same thing with the client? It's coming from the corner, but yes, it's working now both ways. So it's finally running as it should. I can control both avatars, both server and the client independently through the full server client multiplayer game architecture. This concludes this introductory tutorial about Netcode. We have managed to build a working networked server-client application against a few minor difficulties such as server authoritative model used by Netcode. More about it in the next installment of this tutorial. There are several possible extensions to this implementation. The easiest thing to do is to set up the IP address and port for communication between different computers in a local network. To find out what is the IP address and port to which you are connecting, check Network Manager Inspector, Unity Transport, Connection Data. The default value is 127.0.0.1 and the port is 7777. It points to the local host and does not allow for any connection between computers. You can run ipconfig, a system program running from the command prompt, and check what is your IP address. The port 7777 should be fine for most places, and in particular it has been safely opened for all computers in our games lab. Once you get your IP address, put it in the inspector, rebuild the application and try running on two or more PCs. Remember, you must have exactly one host or server and one or more clients. Also important is that projects running from within Unity editor may not work across the network. You may need full builds of the game. And one more thing, download the ultimate version of the Hello World Manager, link available below the video. As usually, I have downloaded it previously and stored on the desktop. Connect all the pieces of the canvas with the script serialized fields, rebuild the project one more time, run and enjoy. With this version, you can configure the server IP address and port. It is also a little bit better written. Thank you very much for watching and don't forget to revisit for more material. Also, subscribe my channel Games Fundamentals.